Adding radicals is quite easy. Here is the property that we're going to be using. The nth root of a plus the nth root of a is equal to 2 times the nth root of a. Now I want to highlight two things here. When I say I've got the nth root plus the nth root gives us the nth root, that means I must have the same index. In other words, you may not add a square root to a cube root. Square roots get added with square roots, cube roots with cube roots, otherwise they're not like terms. Second thing I want to illustrate from this property is we have the same thing inside the radical. So that means we must have the same stuff inside. Now I know that's not quite technical language, so I should probably give you the right word, which is radicand. There must be the same radicand in order to be able to do addition. And then you're just combining the coefficient out front. So here we go. 5 root 7 plus 9 root 7 is 14 root 7. You keep the root 7 as it is and just add the 5 and the 9 out front. We have root 2 plus 2 root 2 plus 3 root 2. That root 2, it really is a 1 root 2. So adding the coefficients in front, we have 1 plus 2 plus 3, which is 6, which is 6 root 2 as the value. On problem number 3, two of these are the roots of 3, and the other two terms have the square root of 2 in them. So we're just going to combine like terms. It's as if we're going 5x plus 4y plus 7x minus 9y. It's all we're doing is combining like terms. So the two terms that have root 3 in them, 5 and 7, add together to make 12 root 3. And the two terms that have the root 2 in them, 4 minus 9 makes negative 5, so minus 5 root 2. And that's as far as we can go on that problem, because we do not have the same radicand on each of these. Number 4, only two of these have the same radicand. So 4 root 7 plus 5 root 7 makes 9 root 7. But then the 3 root 10 cannot be combined because its radicand is different, and the whole number minus 9 cannot be combined because it has no radical with it. So what is inside the radical must be the same in order to add. Now I say that, and then we move on to number 5 here, and right off the bat we don't have the same thing inside. But in this case we can break the 8 and the 50 down. The 8 breaks down into, and I'm just going to make this 2 times 2 times 2. That pair of 2's comes out. It multiplies with the 7 that's out in front, and 7 times that 2 makes 14 root 2. Now moving on to the 50, that is a 25 times 2, and the 25 is a pair of 5's. That pair of 5's comes out, multiplies with the 9 in the front, and 5 times 9 is 45, so I've got minus 45 root 2. Now we've got like terms, and 14 minus 45 makes negative 31 root 2. And that is what we get when we simplify. So let's do another problem just like this. I'd recommend you pause this video, do it on your own, and then check your work. But I'm not going to do that. I'm just going to keep on going here. That 27 is a 9 times 3, and that 9 breaks down to 3 times 3. So I'm going to have a pair of 3's multiplying, coming out as a 3, multiplying with that 8, making 24 on the outside with the leftover 3 inside. Moving on to the next radical, the 12 breaks down into a 4 times 3, and the 4 is a pair of 2's, and that pair of 2's comes out as a single 2, multiplies with the 5 in the front, and gives us plus 10 root 3. The third radical, 75, breaks down to 25 times 3. 25 splits into a pair of 5's there. That pair of 5's comes out as a single 5, multiplies with the 2 in the front, making minus 10 root 3. Now we see that these second two terms cancel each other out, and our answer is 24 root 3. Number 7, a fairly simple problem. The only difference is we have a variable out in front. That's no different. The coefficients 8y and 3y subtract, and we get 5y times the root 15. Number 8, again, kind of the same thing, but with variables involved. This a to the fourth is really an a squared times an a squared. I'm going to write it that way this time. A pair of a squareds come out, multiply with that 11, and you have 11a squared with root b left over. Then in this next term there's nothing to be brought out, so I'm just going to bring that term down, minus a squared root b. And then in this third term we have a pair of a's coming out as a single a, multiplying by the 9a, making minus 9a squared left over root b. So combining like terms, all of these have a root b. All of them have a squareds out front, so I have 11, take away 1 is 10, take away 9 is 1. And so all we have is a squared root b. I've got a little more space left on this paper, so I'm going to do one more problem that wasn't pre-planned. Let's do this. Problem number 9. 3 square roots of 20x minus 7 square roots of 45x. The 20 breaks down to a 4 times 5, and that 4 is a pair of 2's. The pair of 2's comes out, multiplies by the 3, making 6. You've got the 5 and the x left over inside, so 6 root 5x. The 45, 9 times 5. The 9 is a pair of 3's. That pair of 3's multiplies with the 7 out front, making minus 21. Then we've got the 5 and the x left over again. Now we can subtract. 6 take away 21 is 15, and the radicands stay the same, root 5x.